So, Assalamualaikum and hi, my name is Nurul Izzatty. I'll be working with Amirah Khairina, Afiq and also Badrul Amin on this presentation. As a result, we would want to share about our expertise about our subject, which is passive design strategies, as it for our lesson for this semester BCT 533 course, which is on the environmental green studies. So let's begin. In this presentation, we'll introduce about passive design strategies, discussing about the research method for the case study, which is the book garden at UiTM Sri Iskandar, discussing about the case study's result and outcome, and draw some conclusion. As in details, we are about to provide the knowledge and some information about principles of passive design strategies, which including heating and cooling, elements for passive design strategies, introduction to the case building, which is the book garden, the result that we got from the observation and measurement on the case study, and lastly the conclusion itself. So, as the for introduction, what is passive design strategies? What do you know about passive design strategies? A passive design strategies is one that adapts to the local climate to keep the house on a suitable temperature. Depending on your area, good passive design should reduce or eliminate the need for supplemental heating or cooling. And it frequently depends on an active tenant to function. A range of active and passive design techniques can be used to improve a building's energy efficiency. So, could you really guess why is it important to know about passive design strategies? Here, let me tell you now. Passive design strategies help us maintain thermal comfort inside a building without the use of electricity, as heating and cooling require it the most. Using passive design strategies can reduce temperature fluctuation, improve the indoor air quality, and make a home drier and more enjoyable to live in. So, we can easily say that passive strategies really offer us comfortness without endanger the environment. So next, we will be jumping into discussing about the passive heating and also the passive cooling. So, what is passive heating? Easily said that using thermal mass, heat flow and insulation effectively to store, distribute and keep the heat from the sun within your home is known as passive heating, sometimes known as passive solar heating. The purpose of passive solar heating is to maintain a pleasant interior temperature by storing solar heat inside the structure of the building and releasing it when the sun is not there. Passive heating maximizes winter heat gain, minimizes winter heat loss, and concentrates heating where it is most needed. So, many of the features that you really need for passive design heating, which is, for example, orientation and also the thermal mass. It should be designed into the home before it is built. As an example of a passive system for space heating is a sun space or solar greenhouse. Passive system also make use of materials with large heat capacity like stone, water or concrete to store and deliver heat. These are called thermal masses. So we jump into passive cooling. What is passive cooling? In order to increase indoor thermal comfort with a very little energy space or energy usage, passive cooling is a building design strategies that focus on controlling heat gain and heat dissipation in a building. The goal of passive design is to maximize occupant comfort and health while consuming the least amount of energy possible. Applying passive cooling means reducing differences between outdoor and also the indoor temperature, improving the indoor air quality and making the building both a better and more comfortable environment to live or to work in. It also reduces levels of energy use and environmental impacts such as greenhouse gas emission. So I think that's all from me about my topic. So I'll pass the slide to Amirah as for her presentation about the elements for the passive design strategies. Thank you.
Hello, my name is Amirah Khairina, so I will explain more about elements for the passive design strategies. Passive design strategies are based on four fundamental principles, which are climate analysis and comfort, passive heating and cooling, passive cooling, and daylighting. There are several elements of passive design strategies. I will start with building orientation. Building orientation, as we all know, is the process of facing a building in a way that maximizes specific features of its surroundings, such as street attractiveness, the ability to take in a scenic view, drainage considerations, and many more. It all comes down to balancing the project's budget, program, site requirements, and microclimate to determine the best mix of active and passive solutions to use. The next elements is natural ventilation strategies. Controllable natural ventilation should be incorporated into building designs. It is vital to have a very wide range of natural ventilation rates so that the rate of heat transmission between the inside and outside of the building can be selected to the conditions. Ventilation rates are designated to regulate temperature, pollution, and air movement. The thermal capacity of the building must be taken into consideration as well as ventilation with heat reclaim. Third is natural lighting strategies. Natural lighting, commonly referred as a daylighting, is a technique that effectively uses exterior lighting glazing such as windows, skylights, and etc. to bring natural light into your home, and it will minimizing the need for artificial lighting and saving energy. Natural light has been shown to improve the health and comfort of building residents. The comfort, health, and mood for a person is significantly influenced by natural lighting. However, this depends on our locations. 4 is roof. In modern house, an increase in indoor temperature compared to outdoor temperature is a major concern. Because of the overheating indoor temperature, occupants experience this unpleasant condition. Heat is trapped in poor passive design, which influence the rise in indoor temperature. The upper part of the house, which covers the area at the roof, is the most vulnerable to heat caused by high solar radiation and high emissivity levels. Next is building facade. A facade is one side of a building, usually the front. It is an essential component of a building's overall design. It provides the opportunity to give a building personality and character. Facades can come in a variety of shapes and sizes, and they are a great way to architects to show off their skills by bringing a building to life. Although a facade is frequently associated with older and prestigious buildings, any building can create a distinguishable facade. Next is landscaping. Many landscape considerations are made early in the design process. Setbacks, street trees, street alignment, and the use of landscape buffer zones can all be guiding components in many site planning designs. As a result, careful landscape consideration is critical to successfully implementing the passive approach during the early stage of design. Landscape strategy integration necessitates an active IDP in which energy and thermal comfort goals are discussed and understood within the design team. Last is renewable energy. Solar energy is a type of radiation from the sun that can be generate heat, cause chemical reactions, and be converted into electricity for your home or business. The sun is a natural nuclear reactor that emits photons of energy sufficient for our planet to generate solar energy for global energy needs. A solar panel, also known as a solar module, is made up of a layer of silicon cells, a metal frame, a glass casing units, a wiring to transfer electricity from the silicon.
Next presenter is me, Badrul Amin bin Baharuddin, would like to present about research method. First is introduction of the case study building. The case study building selected for this research is located in the architectural studio room at the Faculty of Architecture UiTM Perak Seri Iskandar. The case study is a 5-story building that consists of laboratory, lecturer office, studio room, and toilet. The orientation of the building is facing the north. Next is objective of research. which is the first is to understand passive design strategies. Next, to identify the passive design features element in the selected building and its surrounding. The third one is to observe and record the natural ventilation and natural lighting related to the site selection. Next is to investigate the advantages of passive design strategies for energy efficient building. And the last one, to propose improvement in the passive design building without the use of mechanical system. Next is literature study, which is the information and data that have been used in this research, basically from a research person, which is our lecturer for BCT 533, Dr. Asmat Binti Ismail. Next, the resource from the internet, and lastly, the result from the data from the result and discussion. Next is observation method and measurement method. First, observation method. Basically, all the group members contributed in conducting an observation of the element of passive design in the studio room at Faculty Architecture. The natural ventilation and natural lighting have been observed, and phone Samsung S20 camera have been used in this study to ease recording data and as the evidence in the site. Next is building orientation, material selection, facade, shading and landscaping have also been observed to know the building fulfill the minimum requirement and specification following UBBL, which is Uniform Building by Law. Next is measurement method. In conducting research, it is important to make sure the data taken was accurate and precise. Measurement method have been chosen to determine flow ratio which can determine the air velocity and ventilation in this research. Next is the measurement equipment that have been used in this research. First is lug meter application, and next is measurement tape. Next, let's look into the measurement procedure, which is the first one is all electrical appliances for lighting and ventilation such as air conditioning and fluorescent lamp were switched off. Next, we need to measure the distance at least 3 meters from the window and opening to get the exact location of the lug observation device. The third procedure is all the data were recorded 10 times at 3-minute interval in the book field. And the last one, we need to make sure the device placed in a stable condition.
Result and discussion are divided by two, which are result from the observation of the case study building and result from the measurement of the case study building. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Noor Afiq bin Muhammad Izer. Okay, today I will present about the result from the observation of case study building. The first one is building orientation. One of the components of passive design is building orientation, which need to be established prior to building construction. From the research of this study, the facade of the building is facing to the north, which follows the passive design rules of building orientation. The east side of the building, which only had a 4-panel window, will receive more solar radiation as shown in figure next. Okay, second is natural ventilation. The structure use architectural characteristics to produce positive and negative pressure regions, as well as cross ventilation for the natural ventilation system. Thus, the design outlet opening is slightly large compared to the intel opening to produce higher air velocity. The main opening for the room area is side hinge glass, with the wind directly in from the east of the building as shown in figure beside. Meanwhile, the other opening facing to the west is used as an outlet opening, which is double lift panel door as shown in figure beside. The natural ventilation system is used to maintain the thermal comfort of the room without active temperature control or mechanical means. In addition, certified the fresh air needs to this area. Okay, third is natural lighting. Natural lighting, also known as daylight, is a technique that efficiently brings natural light into your home using entire glazing. So, using less artificial light and using less energy. There is evidence to suggest that natural illumination improves the health and comfort of building inhabited. The study area does not have sufficient natural lighting due to several factors. The natural lighting for the area of the case study had an obstacle. One of the factors is window was tinted, which reduced more natural lighting in the room as shown in figure beside. Fourth is material selection. Building materials are important for passive design in order to maximize the effectiveness of the natural world. This case study found the building used cement brick instead of clay brick. It is because cement bricks are the most widely used type of house built by middle-class people. The reason for using them is that they are cheaper than other bricks. They are also set up as hard in all areas. If we want, we can buy. Also order in any size we like. Cement bricks have almost the same rigidity as clay brick. There are different sizes available, so we can choose the right size for our house structure. Meanwhile, a light shade of emulsion paint is used to finish the areas interior as figure beside. The finishes that were utilized help the natural illumination by reflection light to other locations. Okay, next is building facade. Depending on the design and kind of structure, a building may have one of a number of facade kinds. The facade may play a critical role in the structural integrity of the remnant of the structure, or it may be more ornamental than useful. Based on the case study, the facade of this building contains a few windows and doors. The facade receives minimum sun radiation because the building orientation of the building is oriented toward the north, which is far from rotational light. Then, the building is most likely to gain minimum solar radiation from the sunlight. Next is shading. Natural landscaping or artificial feather like awning, overhang, and trellises can offer to shade. However, based on the case study, the side of the building has an overhang that was erected as shown in figure beside. The overhangs of the building block the radiation of the sun from getting through the facade wall. This is produce lower natural lighting received from the building. Next is landscape. Landscaping refers to any activity that modifies the visible feature of any land. Although it is not just about plant and horticulture, landscaping calls for a certain level of artistic design and horticulture knowledge. The use of landscaping can also be seen in the sculpting of land to improve usability. From observation, this case study building does not provide proper landscaping. There is barely any plant planted inside the yard perimeter. If there were any, the trees seem to want to die because there were no leaves. Only 3 trees remain. Figure beside show the tree plant around the window. Lastly is roof. A roof is a top covering of a building, including all material and construction necessary to support it on the wall of the building, or upright, protecting against rain, snow, sunlight, extreme of temperature, and wind. A roof is a part of the building envelope. The study building used a heat roof for the roof structure. The roofing material used is zinc because it is low maintenance, self-healing, less energy required for manufacturing, and more as shown in figure beside.
Next is the result from the measurement of the case study, which is there are several things to consider to calculate the air ventilation. First, the opening area, which is in this room, we observe at least 2 opening, which is aluminium 3-leaf casement window and wooden double panel door. We also need to measure the floor area, which is 11.4 meter times 9.0 meter and is equal to 102.6 meter square, which is the floor area. Lastly, we need to calculate the opening percentage, which is the total opening area times 100% divided to floor area and is equal to 22.46 alias 22%. The percentage of the study area is 22%. Since the percentage is above 10%, the architectural studio room passed the opening requirement provision for natural ventilation and lighting purposes according to the Uniform Building Bylaw UBBL 1984 Part 3 number 39. Next is the result from the measurement of natural lighting for this case study. As we can see here at the left and right side is the table and chart for indoor lighting lux. From the chart, we can conclude that the natural lighting inside the architectural studio room is not sufficient. The average light in the studio area is 44.1 lux. The highest light entering the area is only 59 lux at 2:05 p.m. Meanwhile, the lowest light entered the area is 31 lux at 1:50 p.m. Architecture studio room has not passed the natural lighting requirement where the acceptable luminance level that have been set up in Malaysia Standard MS 1525/2014 stated that the lighting for working interior such as office and studio should have at least 300 till 400 lux. The main factor of this result output is caused by the tin or film that have been applied on the window surface to block heat and lighting from the sun especially. Other than that, the architecture studio room is depending on lighting system mechanical such as fluorescent light, since the type of work in the study area required them to stay until night to complete their work. Moreover, the weather on the observation and measurement day was mostly cloudy and it also can affect this result. In conclusion, the passive design strategies was proven to be one of the methods to measure and control the local climate by helping to maintain thermal comfort inside the building and minimal use of artificial energy. As certain buildings need heating and cooling the most, passive design strategies can be an alternative to maximizing the comfort and health of the building users while minimizing energy usage. Furthermore, the location of this architecture studio room is located behind La La Land, which is full of trees and can provide shading to the building. The existence of the trees behind the building likely can improve the thermal comfort of the building. Trees and vegetation are an approach to the lower surface and air to produce oxygen and also can provide a cooler microclimate. In the end, it also can counter the urban heat island. That's all from us from Group 6. Thank you.